Hello friends. Uh, in the last session we have completed the preparation methods of the amines. Today we will learn about the chemical reactions of amines. It is the last part of this chapter. Now how many chemical reactions of the amines are there? Then there are total six reactions are there, and the sixth one, it is include again the three subdivided into three types: bromination, nitration and the sulfonations. We will learn one by one first. So first, Hoffman elimination reaction. Always keep it in your mind that this elimination word, whenever it gives, most probably there is the formation of the alkene. That keep it in your mind. Suppose if it is beta elimination, Hoffman elimination, then there is always formation of the alkene is there. So in this first one, we have to prepare the alkene from the amine is there. Now it is also concerned with the quaternary ammonium halide that we have learned in the last session. Quaternary, it means the 4 times, means 4 alkyl group. It is surrounded with the nitrogen, and it is due to the lone pair of electrons on the nitrogen, it is again replaced by the halogen, that is known as the quaternary ammonium halide is there. So by the quaternary ammonium halide, this Hoffman elimination reaction is there to form the alkene. Second one, acylation reaction. In acylation reaction, it means either the amine, it is react with primary amine or the secondary amine. Tertiary amine does not give this reaction because no replaceable hydrogen atom is there. Acylation, it is reaction with the either the acyl chloride or either with the acetic anhydride also we can use. Acyl chloride formula is CH3COCl. Means methyl chloride is CH3Cl, and between CH3 and Cl just we have to put C double bond O, and that is the formula of acyl chloride. Carbylamine reaction, it's very important. In the carbylamine reaction, primary amines only it is given by this reaction. No, secondary, tertiary does not undergo this reaction. Carbylamine, carbyl, it means what? It means foul smell, bad smelling. When the amine, it is react with the KOH and with the reactant with the chloroform to get the bad smell, and whatever the form, it is known as a carbyl is there, and it is known as a carbylamine test is there. Coupling azo group. Coupling, it means coupling. Coupling of azo, it means 2 nitrogen. It is bonded with each other. Whatever form, it is known as the azo group. Coupling azo group is there. Hensberg test. In the Hensberg test, there is the reaction of the primary or the secondary amine with the benzene, sulfonyl chloride, and whatever the product we are getting, that is known as the Hensberg test is there. And in the electrophilic aromatic substitution of the amines, in this case, we have to take the aniline, means benzene ring attached with the NH2 group, that is known as aniline, react with the bromine, react with the nitration, it means with the nitrogen mixture, and react with the sulfuric acid H2SO4, and for this sulfonation the main word is Zweiter ion. So this you have to note down in your notebook first. So 6 reactions are there for the amines. Now let us start with the first reaction, that is the Hoffman elimination reaction. As I told you before also, when the suppose the tetra alkyl ammonium halide, when it is heated with this moist silver oxide, then it under halogen group is replaced by the OH group to form the hydroxide, and which is the deliquescent crystalline solid, and on strong heating it undergoes the beta elimination and to form the alkene, and it is called the Hoffman elimination reaction. In the Hoffman elimination reaction, for example, tetra alkyl ammonium halide. For that, suppose if we take N triethyl, suppose N triethyl propyl ammonium chloride. This example is given in your textbook. We can write any other example also. But in this case, suppose if we take this N triethyl propyl ammonium chloride, then how to write this structure first? Then first one, ammonium, so it is nitrogen first. Both this side it is there. Now it's a triethyl group. So this nitrogen, it is connect with CH2, CH3, 3 times, because it's a triethyl and propyl ammonium chloride. And propyl group, it is before this nitrogen. Propyl group is CH3, CH2 and CH2. This is the structure, and N plus and the chloride. So it is, suppose chloride, and it is the Cl minus. So this is actually nothing but it is the quaternary ammonium halide group is there. When it is treated with the moist silver oxide AgOH, it's a heating sign because it is heated, and on the arrow we have to write moist Ag2O, silver oxide Ag2O. Now how the reaction takes place? This Cl combined with Ag. So AgCl will be the byproduct, and it's if we does not mention, then it is also okay. It's AgCl. Whatever left, just we have to join this. So CH3, CH2, CH2, N. Now this CH2, CH3, we have to just write in the split up form. So this nitrogen is surrounded by the 3 ethyl groups in this way, and it's plus sign, it's already present plus sign, and the OH minus. So just only we have to remove this chlorine group by this OH group. So that is the living group and attaching living nucleophile. Cl, it is replaced by Ag, and in that place we have to just put the OH. So this full, it is plus sign and this is negative sign, and it is known as the NNN triethyl propyl ammonium hydroxide. On strong heating of this, we just write here, it's minus AgCl. On strong heating, this compound, now how this presentation, this CH2 and CH3, it will be given out of the 3 ethyl group. One, it is given out, and to form double bond CH2, means one hydrogen given out from this CH3 becomes CH2, and one hydrogen combined with this OH to form water molecule H2O is there. And now whatever left, that we have to join this CH3, CH2, CH2, N, again 2 lone pair of electron we have to show, and CH2, CH3, CH2, CH3, and this whatever the product we are getting, it is NN diethyl propyl amine is there. So this is the first reaction, Hoffman elimination. Once again I repeat, in this case they have given the quaternary ammonium halide. And for that the example is given NNN, 3 times ethyl group. So I have written ethyl, it means C2H5, or either write in the splitter form CH2CH3 3 times. So it's a triethyl. Propyl, because nitrogen left hand side propyl group, 3 carbon atoms are there, 1, 2 and 3. So it's a propyl, and it having the total 4. So it is the ammonium, and Cl, it means it is the chloride group is there. When this group, quaternary group, it is the heated with moist silver oxide, and moist silver oxide, it means nothing but AgOH. When the AgOH it is heated, then so we are getting the NN, just we have to write the changing the name. Instead of this ammonium chloride, we have to put the ammonium hydroxide. That is only the difference. When this hydroxide group, it is strongly heating, then from this CH3, one hydrogen given out, combined with this OH to form the water molecule. And this group, it is given out in the form of the alkene, it means ethene we are getting. And whatever left is this propyl group and the 2-ethyl group, it will remain as it is, but just don't forget to put 2 dots on the nitrogen. It indicates there is the still one place is left. So 2 nitrogen, and it is known as NN diethyl propyl amine is there. Now the second reaction, it is the acylation. In the acylation, as I told you before, we have to add the this acetyl chloride or the acetic anhydride in the primary or the secondary aromatic or the aliphatic amine. Then we are getting this group NHCO group. So if this NHCO or CONH group, it is known as nothing but amide is formed by this reaction. Now suppose if we take one of the example, ethyl amine or ethane amine, suppose C2H5 NH2, suppose 2 dot we have to put. So it is the structure of ethyl amine or ethane amine. When it is react with the acetyl chloride, CH3CO Cl group, it is known as the acetyl chloride. In presence of pyridine, because this is to form the amide group. This amide, it is the less basic than the amine. Hence, we have to use the strong pyridine group, so which neutralizes the HCl which is produced during the reaction. Is that this question can be asked, why pyridine is used in this reaction? Because by this group, amide group is formed, and amide which is less basic than the amine group is there. Amide is less basic than the amine, so which neutralizes the reaction during which the HCl it is produced, hence pyridine is used. Now let us see the reaction, how the reaction takes place. The C2H5 NH, this plus group, it is there, plus group, and this one compound, just we have to rearrange this group, hydrogen, because we have to join this group. C, this we are adding something, so this double bond, it is removed to form a single bond, O, and minus sign on it, and the chlorine group, and CH3 group is there. This is the unstable we are getting. This is unstable compound we are getting, which is immediately it is convert this HCl group. HCl it is formed during the reaction. So, and the main product is C2H5 NH CO CH3 group is there. So it is C2H5 NHCO CH3. The name of this compound is N-ethyl amide is there. N-ethyl acetamide, or either we can say it is the ethanamine also, ethanamide. It is known as N-ethyl ethanamide. This ethanamide, it is the common for every reaction, because at the end we are getting this NHCO group, and NHCO, it means amide group is there, and in this case there are 2 carbon atoms, so it is ethane, so it is ethanamide is there. Now the same reaction they have given either with the N-methyl aniline, and in this case C2H5 we have to replace by methyl group CH3, and one hydrogen it is replaced by C6H5, and that is the formula for the N-methyl aniline is there, and the reaction will remain the same. Suppose CH3 N C6H5 and NH. This is the formula for the N-methyl aniline group is there. Aniline means C6H5. When it is react with the CH3COCl to form what? Then the reaction will take place in the same way. Just we have to write CH3 N C6H5 CH3 is there. So this is the product and HCl is the byproduct. So what is the name of this compound? It is known as N-methyl N-phenyl ethanamide. Why ethanamide is there? Because the 2 carbon atoms are there, and it is known as a ethane, and NHCO group, it is known as the amide group is there. So it is N-ethyl N-phenyl ethanamide is there. Okay, for the carbylamine reaction, third one, it is carbylamine reaction. In this there is the amine, primary amine, aliphatic or the aromatic. It is react with the chloroform CHCl3 and with KOOH, then which gives the bad smelling, foul smelling, and that is known as a carbylamine, and that reaction is known as a carbylamine reaction. This reaction is given by only primary amine. Secondary, tertiary do not undergo this reaction. How to explain this reaction? Suppose if we take the primary amine example, C2H5 NH2, when it is heated with chloroform CHCl3 plus KOH, heating sign because it is heated, then what will happen? This chlorine combined with potassium, so KCl is formed. KCl, chlorine is 3, so make this 3. Potassium becomes 3, so make this 3 KOH. Now this 2 hydrogen combined with this 1 hydrogen combined with this 3 OH group to form 3 H2O is there. And whatever just left, we have to join the C2 H5 and C, and it is known as ethyl isocyanide is there. So this reaction can be given by, if instead of C2H5 if we put C6H5, then also it will remain same. Instead of C2H5 it becomes phenyl isocyanide we get. So in this board NEET exam, they have asked to form the carbylamine, which reagent is used as a reactant. Then either primary or aromatic or the aliphatic amine can be used for the carbylamine test. Now after the third reaction, the fourth one is the azo coupling. Azo, whenever this azo group, azine group, always remember, keep it in your mind that there are the 2 nitrogens are there, connect with each other. That we had done before also, N2Cl. It means it is the diazo group is there. In this azo coupling group, first one, the arene disonium salt. Suppose benzene disonium chloride. Suppose if we draw the structure, benzene diazonium and the chlorine. This is the nitrogen. It's a N plus group. It's a benzene diazonium chloride group. When it is strongly react with the certain reactive aromatic compounds such as phenol, suppose, or either any aromatic amines, it gives the azo compound, and that reaction is known as the azo coupling. Suppose this is known as the benzene diazonium chloride. When it is react with the strong aromatic group, suppose phenol, then in presence of either base, alkali, then how the reaction takes place? Then when this two benzene ring, it is combined, that time this, from this carbon, hydrogen is given out. That hydrogen combined with this Cl, so the byproduct is HCl. Whatever left, we just have to join. So it's a benzene ring. We are adding something, so this triple bond remove to form the double bond. Now this Cl, it is given out, so direct benzene ring, and OH group in the same position is there. This is the azo coupling and plus HCl. The name of this compound is para hydroxy azo benzene. Why para-hydroxy? Because of fourth group, 1, 2, 3 and fourth. Fourth, it means para. To the para group, there is the hydroxy, means OH group is present. And this N and N is known as the azo and benzene ring. So it is known as the azo benzene is there. So this is nothing about the azo coupling group is there. In this reaction, instead of phenol, suppose if we use aniline, then instead of OH, we have to just put NH2, and in this product also we have to write the NH2. But the name of this compound is para, instead of hydroxy, it becomes the amino. Para amino azo benzene. So this reaction, it is given by the two benzene group. They are reactive with each other to form the coupling. So it is known as the coupling reaction is there. After the fourth reaction, the fifth one is Hensberg test. Hensberg test, for this test, we have to use the benzene sulfonyl SO2 and the Cl. It is known as benzene sulfonyl chloride. Formula is C6H5SO2Cl. Last 2 years back in a board exam, question was there. Draw the structure of benzene sulfonyl chloride. Either you can write this also, C6H5, sulfonyl it is SO2 and chloride it means Cl. Either we can write in this way also, benzene SO group, it is 2 times double bond, and the Cl it is benzene sulfonyl chloride. This reagent is known as the Hensberg reagent is there. So this test is known as a Hensberg test. When this benzene sulfonyl chloride, when it is react with either primary or the secondary amine, suppose if it is react with this is the ethyl amine is there, NH 1 degree amine. That time what happened? Cl and hydrogen it is combined to form HCl as a byproduct. And whatever left, we just have to write in the combined form. So it is benzene, SO, SO, double bond O, double bond O. Then Cl it is replaced, only direct NH, C2H5. And this is known as the N-ethyl benzene sulfonamide is there. Sulfonamide is there. Sulfonamide because it is the SO and the NH group is there. So it is known as a sulfonamide is there. Suppose instead of the primary amine, if we use the secondary amine, then the reaction will remain same. Only instead of hydrogen, suppose if we put C2H5, so it is the diethyl amine. And here also we have to write it is C2H5. And the name of this compound is N-diethyl benzene sulfonamide is there. After the fifth reaction, the sixth one is electrophilic aromatic substitution. In the aromatic group, there is the substitution group is there. Let us start with the first one, bromination. In this bromination, suppose the example, in all this example, we have to take the aniline. It means C6H5NH2 group. When the aniline in this case, when it is react with the bromine water at room temperature, this is the aniline structure. When it is react with the bromine at room temperature to form the white precipitate of the 2,4,6 tribromoaniline we are getting. Now 2,4,6 aniline structure. Second position we are. Fourth position. And sixth position. So this is the structure of 2,4,6 tribromophenol white PPT we are getting, and wherever we are attaching bromine, in all these three places hydrogens are given out. That hydrogen it is combined with Br to form HBr. So we have to balance this reaction. So bromine it is total 610. So it's a 3Br2. So 3 2s are 6. Make it 3. So this is the first reaction, bromination. Now after the first bromination, the second is the nitration. In this case, aniline when it is the heated with, it is react with the nitrogen mixture. As I told you before also, nitrogen mixture, it is the mixture of concentrated HNO3 plus concentrated H2SO4. When it is undergo the heating with the nitrogen mixture, that time the nitration it takes place, and nitration it means NO2 group is introduced to this aromatic ring and it attached to the ortho, para and the meta position. So first product we are getting NO2 group, we are getting the para nitroaniline, it is 51% we are getting. Second possibility, NO2 group is attached to the meta position, it's a 47%. And the third is the orthonitroaniline we are getting, only the 2% we are getting. So in this way, aniline when undergo the nitration in presence of nitrogen mixture, we are getting the 3 different nitration products. That is, first one major product is para-nitroaniline, after that the meta-nitroaniline and the ortho-nitroaniline, only the 2% we are getting. But suppose if we want the para-nitroaniline in the large amount. So that time this reaction is not considered. That time this aniline group, it is first gets protected. This position of the aniline, it first gets protected by the acylation. After the acylation, it undergo the nitration to form the anilide, and that anilide gives the para-nitroaniline group is there. So let us see by the reaction. Now this is the second reaction of the nitration only is there. Why to get this direct para-nitroaniline as the major product? So by this method we can get the major product of the para-nitroaniline. Suppose this aniline, it is react with the acetic anhydride, acetylating agent CH3CO twice oxygen in presence of pyridine. Then this position it will be protected to form NHCOCH3. It is known as acid anilide is there. So first step, it is react with the acetylating agent acetic anhydride in presence of pyridine to form this NH2 group converted to the anilide group, and it is known as NHCOCH3. This group, it is undergo nitration. It means concentrated HNO3 plus concentrated H2SO4 to give what I change only in this step, NHCOCH3, it will remain as it is. Just I put NO2 group to the para position. So it is known as the para-nitro acid anilide. And in the last step, this group, anilide group, undergo hydration. Then this group again changes to aniline group. It will remain as it is, and it is known as the para-nitroaniline. So question can be asked, by which method we get the para-nitroaniline in the maximum amount? Then by this method, by acetylation, then nitration, and then hydration, hydrolysis. Then we are getting the para-nitroaniline as the major product is there. Now after the bromination, and the second is the nitration, the third reaction is the sulfonation. Sulfonation, it means obviously it is the addition of the sulfuric acid is there. Suppose aniline, when it is the react with the sulfuric acid, H2SO4, to form what? Then one from this hydrogen combined with this NH2 to form NH3, and this HSO4 minus. So we are getting the anilinium hydrogen sulfate. It is known as anilinium hydrogen sulfate. Just I have added to all this group in this. So NH2, one hydrogen if it is given, so it becomes NH3. If one hydrogen is given, it becomes only H. So it is NH3, HSO4, and just put the sign plus and the minus. It is known as anilinium hydrogen sulfate, which is undergo heating. If it is heated strongly, 453 to 478 Kelvin. Suppose at this temperature, that time it is again converted to this group NH2 in the same place, and to the para position we have to just put the SO3H, and this SO3H group and NH2, it is nothing but the para amino benzene sulfonic acid. Either it is known as a sulfa-anilic acid, it is known as. This sulfa-anilic acid, it is known as the dipolar ion or Zweiter ion. This question can be asked, why it is known as the Zweiter ion or the dipolar ion? Because in single molecule, NH2 means base is present and H it means acid is present. So only one molecule which is act as dual, an acid as well as the amine group is there. And in this case, this hydrogen, it can be changes to each other. So to form NH3 plus SO3 minus, and it is nothing but the Zweiter ion is there, which is act as both acid as well as the base, hence it is known as a dipolar ion. And this hydrogen can be shifted either to the base, either to the acid to form the Zweiter ion is there. So in by the same times we have completed the reactions of the amines, and the next session we will start with the new chapter. Thank you.